This is Unit 10. For the 10th unit, we'll be in Chapter 9, so we're going to start with Section 9.1. Our goal is to use similarity in right triangles. So let's go back and review the parts of a right triangle. In our right triangle, the two sides that form the 90-degree angle are the legs. Opposite that 90 degrees is the hypotenuse. And what's drawn on here is the altitude that goes from a vertex to the opposite side at 90 degrees. And we're going to talk about some properties that right triangles have and what happens when we draw this altitude in. If the altitude is drawn to the hypotenuse of a right triangle, then the two small triangles formed are similar to the big original triangle and to each other. So we will have three similar triangles, the large original triangle and the two that are formed when the altitude is drawn in. Here's a picture of that. So here's our altitude that's been drawn into our right triangle from this vertex C to the opposite side to the hypotenuse at 90 degrees. And altitude is like a height. So it says which triangles are similar. We're going to have three triangles that are similar. We're going to start with our large triangle. And on our large triangle, I'm just going to call this triangle ABC. Now, when I go to name the similar triangles, I want to keep those congruent angles in the same order. So if I look at ABC, A is the 60-degree angle, B is the 30, and C is the 90. So when I look at the smaller similar triangles, I want to keep that order 60, 30, 90. So let's look at kind of the larger of the two small triangles. And again, I want to go 60, 30, 90. So 60 is angle A, 30 is this angle C, and 90 is our angle D. So triangle ACD, and that is similar to. Now let's look at the smaller of the two small triangles. Again, we want to keep that order 60, 30, 90. So we're going to look at this triangle and go 60, which is C, 30, which is B, and 90, which is D. So CBD. And those are our three similar triangles. Remember, when we're talking about similarity, you need to use your similar symbol, especially when we talk about why triangles are congruent. Why triangles are similar. In Unit 9, back in Chapter 8, we talked about the geometric mean. That the geometric mean, you had your mean on the top of the right-hand side and the bottom of the left, where the means go. And our extremes, whatever it's the geometric mean of, go in the top left and the bottom right, because those are the positions for the extreme. So we're going to talk about some properties and some geometric means for right triangles. In a right triangle, the altitude, that height that's drawn in that's 90 degrees to the hypotenuse, is the geometric mean for the two parts of the original hypotenuse. So let's look at a picture. This will be our first formula. We have our altitude that's drawn in and forms a right angle with the hypotenuse. That is the geometric mean for these two parts of the original hypotenuse. We're going to call those hypotenuse segment 1 and hypotenuse segment 2. So our formula will set up that the altitude is the mean. So I'm going to put the altitude in the means position. And what it's the geometric mean for, those are going to be our extremes. So my extremes are the hypotenuse segment number 1 and the hypotenuse segment number 2. And this is the first formula that you need to know for this unit. Okay, so let's work through some examples. I'm going to go ahead and label my triangle so I can see exactly what's happening. So we have this triangle ABC, and altitude is drawn in CD, that's 90 degrees to the hypotenuse. That altitude CD is 12. AD, from here to here, is 8. And DB, the other part of that original hypotenuse, we're looking for. And always call what you're looking for X, so that when you find X and you feel like you're done, you really are done with the problem. So again, the altitude is the geometric mean, so I'm going to put that in the means, of the two parts of the original hypotenuse. So those are my extremes, the 8 and the X. To solve, we're still going to be cross multiplying. So 8 times X is 8X equals 12 times 12 is 144. And if we divide by 8, we find that X is 18. Let's work through another example. Again, I'm going to label my triangle first. It's very helpful, especially taking quizzes or tests. Draw out your triangles and label them so you can see what's happening. CD is 4. That's our altitude. AD, the first hypotenuse segment, is 2. And I'm looking for DB, the second hypotenuse segment. Again, the altitude is the geometric mean, so those are the 4s, of the 2 parts of the original hypotenuse, the 2 and the x. Cross multiplying, we have that 2x is 16. And if we divide by 2, we find that x is 8. So again, we're using the geometric mean, what we talked about in the previous chapter. For number 3, AD is 3. So hypotenuse segment 1 is 3. DB is 9, hypotenuse segment 2. And CD, the altitude, is what I'm trying to find. So I'm going to call that x. Now again, when you set this up, your altitude goes in your means. So I have x and x. That is the geometric mean for the 2 parts of the original hypotenuse. So those are your extremes. So I'm going to put 3 and 9 in for the extremes. Cross multiplying, x times x is x squared. 3 times 9 is 27. To get rid of the square, we do the square root. 27 doesn't have a nice square root, so I'm going to do a factor tree. I know that 9 and 3 go into 27. And if you can use a perfect square to do your factor tree, it's going to make it much easier. There's my perfect square. I get a pair of 3s and a lonely 3. So x is 1 from the pair of 3s, and the lonely 3 stays in. So it's 3 rad 3. If you do not know your altitude, when you set up your geometric mean, you will have to do a square root and deal with an x squared. Number 4, AD is 4. DB is 16. Again, CD, our altitude, is missing. Go ahead and pause. Try to set this one up and solve. So CD, the altitude, is my geometric mean for the 2 parts of my original hypotenuse. Those are my extremes. Again, x times x is x squared equals, crossing the other direction, 4 times 16 is 64. The square root of 64 is 8. And remember, square roots really do have a plus or minus answer, but because we're dealing with lengths of sides in our triangle, lengths of altitudes in our triangle, pieces of the hypotenuse, we're only going to use that positive answer. Number 5, DB, hypotenuse segment 2 is 6. AB, the entire hypotenuse, is 14, and CD is missing. Now, the altitude is the geometric mean, so I'm going to put my x's in for my mean, of the 2 pieces of the hypotenuse. So no matter what, you need to have the hypotenuse segment 1 and the hypotenuse segment 2. I know hypotenuse segment 2 is 6. To find 1, I'm going to take the whole 14 minus 6 and use an 8. Again, cross multiplying, x times x is x squared equals 8 times 6 is 48. And when we do the square root, we're going to do our factor tree. Again, look for perfect squares. I know 16 goes into 48 3 times. 16 is the one I want to use preferably because I get a pair of 4s and you could stop the pair. So 1 from the pair comes out and our lonely 3 stays in. So x is 4 rad 3. Do not give decimal answers. They're not exact. You need to simplify your radicals. The next theorem, theorem 9.3, says in a right triangle, the leg is the geometric mean. So the leg is the one I put in the mean spot for the entire hypotenuse and the hypotenuse segment that's adjacent to the leg. Remember, adjacent means next to. So the leg is the mean. That's the one I used twice in my means place for the entire hypotenuse. That's my first extreme. And whichever piece of the hypotenuse that's adjacent, that's closest to that leg you're given. So you really need to watch which leg you have to know which piece of the hypotenuse you need. Okay, let's look at the picture for Formula 2. This is the second formula you need to know for this unit. So the leg is the geometric mean. So that's the one I'm going to put down twice in my means place. Leg and leg. So my extremes are the whole hypotenuse, and the hypotenuse segment that's adjacent, that's next to it. So if I'm using this leg that you see at the bottom of the triangle, I'm using this hypotenuse segment that's adjacent and the whole hypotenuse. Where if I'm using this leg that I just scribbled on in red, I'm using the piece of hypotenuse closest to it and the whole hypotenuse. So you really have to watch which leg you're using. So let's set this up in example 6 again. First thing I'm going to do is label a triangle so I can visually see what's happening. Make sure I have the parts I need. AD is 4. AB, whole hypotenuse, is 9. And AC is what I'm looking for. That's X. So my leg, either AC or CB in this picture, the legs are the ones that meet to form the right angle. The leg is the geometric mean. That's the one we're going to use twice. For the whole hypotenuse is 9, and the hypotenuse segment that's adjacent to that leg. So the little piece of hypotenuse in the original triangle that's closest to the X. So 4 is the one that's closest there. Cross multiplying, X times X is X squared. 9 times 4 is 36. When we do the square root, we find that X is 6. Example 7. Again, label your triangle first. CB, okay, CB is the leg that's at the bottom of the screen, is 10. AB, whole hypotenuse, all the way over, is 25. And DB, which is this piece of hypotenuse, is what I'm looking for. Okay, so my leg, one of the sides that forms the right angle, is the geometric mean, so I'm going to put the 10 down twice. For the whole hypotenuse, whole thing is 25, and the hypotenuse segment that's adjacent to the leg, so closest to the 10 is the X that I'm looking for. Cross multiplying, 25 times X is 25X equals 10 times 10 is 100. And if we divide by 25, find that X is 4. So you really want to watch and just make sure you have the piece of the hypotenuse that's adjacent to the leg that is being discussed in the problem, the one that's closest. Number 8, AD is 5. So AD is this part of the hypotenuse. That's going to be 5. AB, the entire hypotenuse, is 8. AC is the piece I'm looking for. So AC is my leg. That's going to be the geometric mean. For the whole hypotenuse AB is 8. And the hypotenuse segment that's adjacent to that leg, adjacent to AC, is AD. So I'm going to put the 5 in. Cross multiplying, X times X is X squared equals 8 times 5 is 40. To solve X squared, to get rid of the squared, we do the square root. Again, I'm looking for perfect squares. So I'm going to use 4 and 10. 4 gives me a pair of 2's. 10 is going to give me a 2 and a 5 that will not pair up. So I have a pair of 2's, so a 2 comes out. Lonely 2 and a lonely 5 multiply back together, and we get 2 rad 10. Do not give decimal answers. Number 9, AD is 3, DB is 6, and CB, this leg, is what I'm missing. So I'm going to call that X. If you make what you're looking for X, when you get finished with the problem or you finish finding X, you're actually done. That leg X is the geometric mean. For the whole hypotenuse, now I wasn't given the whole hypotenuse, but I can certainly find that. I have AD is 3 and DB is 6, so my whole hypotenuse AB is 9, so we're going to use 9. And the hypotenuse segment that's adjacent to the leg, the one that's closest to the leg CB, is the 6. So that's the one we use on bottom. Make sure you have the entire hypotenuse and the piece of the hypotenuse that's closest to the leg. Cross multiplying, X times X is X squared. 9 times 6 is 54. To get rid of the squared, we do the square root of both sides. Again, I want to try to use perfect squares, so I know that 54 is 9 and 6. And I use that because 9 turns into a pair of 3's. This is a 3 and a 2. I have a pair of 3's, 1 3 comes out. Lonely 3 and lonely 2 multiply back up, and we get 3 rad 6. We'll be working on handout 10A when you come into class.